We are live. I wanted some more examples. So, the directions on these problems, I believe, say find the absolute extrema of the function. So can you guys remind me yesterday, and for those who are gone, what is an absolute extrema? Maximum or minimum in what sense, though?
The absolute.
The absolute, what's that mean?
Entire domain.
For the entire domain if they're not specifying an interval or on that particular interval. Okay? So we talked about the extreme value theorem, which guaranteed the possible existence of an absolute max and an absolute min, but you had to be what to satisfy it and be guaranteed that it's going to happen? You had to be closed and continuous. So what do you guys think for this guy? Is it closed? Duh. Is it continuous on that interval?
Yes.
I hear some hesitation. That's good, because what kind of function is this? A rational function, which could have asymptotes, does it?
No.
No, because is the bottom ever 0 for x squared plus 1? It's clearly always positive, so this thing, the extreme value theorem guarantees we've got to have an absolute min and max this time. So let's find them now. That's the most important part, is actually getting them, mechanics. So how do I find them? Take the derivative first, okay? So we go f prime. This time we're going to have to use quotient rule, so help me. Is that right? There's the top and derivative of the bottom. For x squared plus 1 squared. We might want to expand that out when we simplify, because we've actually got to do something with the derivative now. So simplifying is going to start to matter a lot more in this chapter. We'll just see what happens though. So I'm going to distribute on top. Remember, leave your minus outside. Careful on that. Let's see. So what do we have up there? Negative 2x squared plus 2 for this. Okay, so now, the judgment on simplifying. What should we do? Should we try to be clever and do some clever factoring or something? Maybe so. What are we trying to do with this derivative to find the extrema? Setting it to 0 or does not exist. We've got to think about those two possibilities, right? So I don't think this one's ever going to be does not exist, does it? Can the bottom be 0? So you check the bottom equals 0 to see if it doesn't exist anywhere, and I don't think that can be 0. So we could say that even in our notes, just the bottom's never 0, so we're not going to get any what from it? Use the right vocabulary from yesterday. Katie and Mackenzie weren't even here, right? We're not going to obtain any. I used it in the test a second ago. Critical points, which is another way to say extrema, right? But I like that word. We're not going to obtain any critical points from the bottom. From the top, we might. So from the top, we could just set it to 0 and solve. And say, all right, I think we're going to get at least 1. Oh, yeah. We get plus or minus 1, don't we? Let me square root there. Okay, so it looks like we have 2 critical points to check, but we've also got to check the edges. It could happen there too. All right, let's see. Was there a nicer factoring way that we could have approached this? I don't know. Like, those share a 2. I could even pull out a negative 2 if I wanted to and get that. But will that cancel with anything on the bottom? Not quite, but a lot of your problems, maybe not in this section, but at least coming soon, they're going to have things like that where you can make your life a lot easier by simplifying. We'll see examples, okay? I'm guessing there's probably a couple in yours like that. So let's check. Let's do the table. So I'm going to check x. What should I be checking x, these x values at? Where? I should be looking at the y values. Very good. And I should also throw in these guys. It doesn't really matter what order you do this in the course. I just like to do it for housekeeping sake. So we're sticking these into f of x, not the derivative. So if I put this guy in, I'm going to do a little scratch work over here. It's negative 4, 4 plus 1, It's negative 4/5. Okay, putting negative 1 in, that's negative 2 over 2. Is that right? So it's negative 1. If I put 1 in, I get 2 over 2. That's 1. If I put 2 in, I get 4 over 5. 4/5. That one wasn't too bad to plug into. So, how do we say this? The benefit of those who are not here especially.
Absolute extreme.
So where is the absolute maximum? Where is the absolute maximum?
2 with 1.
One occurring at one.
At 1,
Yeah.
that's where it's happening. And what is it? It's 1. So that's how you phrase that. So we say, for those of you in the video, we say there is an absolute maximum value of f on this interval of 1, and it happened at 1. Okay, that's the best way to write it. And there's an absolute minimum of negative 1, and that happened coincidentally at negative 1. Okay, so that's how we say that one. Okay, so another one, number 36 out of the book. Same question, find the absolute extrema. First we'll proceed by finding the critical points. And how are we doing that again? Take the derivative. So we'll go dy dx, I think, this time. 2x gone, derivative of cosine is? Okay, so we're setting that equal to 0. We don't have to worry about doesn't exist. Why? Because like 2x is a line, domains everything, sine of x is a wave, domains everything, there's no asymptotes or anything like that in there, right? Okay, so never going to not exist, but it is probably going to be 0 in several spots, I'm guessing. So, how can we do that? That's interesting, because that's like a combo trig and stuff function. We might have to use our calculator. So we're only looking between negative 1 and 3. Does the extreme value theorem apply? Just thinking about this. Is it continuous and closed? Yeah. So we know they've got to exist. Maybe they're just the edges though. Maybe there's no critical points. I don't know. I can't factor out, right? Because that's locked inside the sine function. So I might have picked a hard one here. Dang it. So, I can't factor. I don't think you can use any kind of identity to turn this into just like that, can you? Maybe you could use some kind of weird triangle. I don't want to. I think we've got to maybe like guess and check this or use our calculator or something. I mean, this is not as easy a problem as some of those other ones. So where is negative 2 times something equal to the sine of that something? So we might go to our calculator. We might like guess and check, or a smarter way if you have your calculator is to graph it. So why don't you guys go and graph it and find the x value. If you're watching the video, you want to pause it, graph it, see where those intersect. And remember, you're only looking at where they intersect between negative 1 and 3. They might intersect other places, I bet they do, but we don't care about those places. Okay, so hopefully you just like looked at your calculator and did what I did and went like, why am I using my calculator to do this? Like, come on, like I can graph a line through the origin down 2 over 1. Sine wave, like the most basic sine wave, I think goes like this, doesn't it? It's the only place they intersect ever is at 0. I don't think they intersect anywhere else. I mean, maybe this dips down far enough, but if you think about the slope here and stuff, you're going to find that no, it doesn't. So the answer is x equals 0. So if we do our little chart, we're going to check the critical point of 0 and also the edges. This isn't f of x. Be consistent with my names. Let's see if we can do this. So negative 1 squared is 1, minus 2 is negative 1, minus the cosine of negative 1. If I put in 0, I get 0 minus 2. Cosine of 0 over here, what's the x-coordinate on the unit circle? 1. So that's negative 3. If I plug in 3, 3 squared is 9, minus 2 is 7, minus the cosine of 3. I don't think the unit circle can help us with the cosine of 3. So that'd be the point where, what would Isaac Newton have done? Does he have a graphing calculator? Does he have any kind of calculator?
Yes.
Does he even know what a calculator is? I'm pretty sure that doesn't happen until like the 1920s. So, no. What's Isaac Newton do? Is Isaac Newton just like, I'm out? No. I think what Isaac Newton would have done is a couple things. He might have been extremely clever about a combination of things using identities from the unit circle to build 3, like, you know, pi over 4 plus like 5, and like all kinds of clever ones in there and stuff with identities. He'd probably have either done that. I think that's probably what he would have had to do because he's on the cutting edge right now. So that's what he'd have had to do. So his life would suck, but Isaac Newton loved doing stuff like that. So actually he'd be like giddy almost. You'll see a video. I'll show you a video about what he's like. They do a good job besides our book. What anyone after him would have done, though, and maybe even at his time, is they'd have pulled out a book that had a cosine calculated to a lot of values, and they'd find 3 in the book, write it down. So they'd have a big long book just for cosine and sine and tangent, and it'd have all these different values. For us, though, what does this come out to? Can you guys help me? Both of these, what do they come to? Even if the book existed during Isaac Newton's time, he wouldn't have used it. He'd have been like, cosine of 3, yeah, it's like a challenge. Except to him, it probably wouldn't be a challenge, but it would require some writing. He liked that kind of thing. So. For which one? This one? 7.98. Okay, and this one? What mode should your calculator be in when you do this? Radians, better check. That sounds right to me. These values sound right. These sound right to me. Okay, so to answer the question, we would say the absolute maximum occurs at 3 and is 7.98. That's how I want to see it. And the absolute minimum occurs at 0 and is -3. You'd miss points on the AP test if this had happened to be a question, unless you left your answer right here in the exact form, then you wouldn't miss points. If you wrote that, you'd miss points. Why? Not 3 decimal places. Make this have an extra decimal place or 2. Okay?